Hi everyone, I am Karim, and in this video I'm going to deploy 101 EC2 instances to AWS. I'm going to use Terraform to build the infrastructure. So I have this tool right here, Cloudcraft, which I'm gonna use to visualize the end result of my infrastructure. So I'm gonna deploy 101 EC2 instances. One of them is going to be in a public subnet, and the other 100 will be in a private subnet. Each EC2 instance will have a hosted web server, and it will communicate with the next web server online. This will make sense once we start implementing it. I'm going to start by setting up my public EC2 instance. So this one needs to exist inside a public subnet. So I need first to create the VPC and create the public subnet. I'm gonna call it public subnet. So to make our subnet public, we need an internet gateway, and we need to associate a different route table and route all traffic to this internet gateway. So this internet gateway needs to exist inside the VPC. Alright, so I have this associated route table that will route all traffic to this internet gateway. That's how we can make our subnet public. But if I build this infrastructure right now and I try to log into my EC2 instance, I will not be able to, because the default security group will not allow SSH access or port 80 from outside world. So I'm gonna create a different security group, and I'm gonna call it public security group here. So this security group will allow SSH access and port 80 from my IP address only. So I'm gonna try to follow least privilege principle here. Next, I need to create the 100 instances in the private subnet. I'm gonna just create one of them, and the rest will be exactly the same. So that's all we need actually for a private subnet, right? But for our EC2 instances to be able to install packages and install updates, it needs to have access to internet. But we don't need the internet to have access to these EC2 instances. So for that, we can use NAT gateway. And to set up a NAT gateway, we need an elastic IP address, and we need to put it inside a public subnet. So I'm gonna put it inside this public subnet that I created earlier, and I need to associate an elastic IP address with it. Also, for my EC2 instance, I'm gonna associate an elastic IP address so that whenever we restart our machine, we will have a static IP address. It will not be dynamic. And to continue set up my private subnet, I'm going to create a route table and associate it with this private subnet instead of the main route table. And this route table will route all traffic to this NAT gateway. Alright, and also for other instances in the same VPC to be able to SSH to this instance and to access port 80, we need a different security group as well. Alright, I think that's all I need to build for the infrastructure. Excuse me. So right now I am on an empty AWS account. I made sure to remove everything before I started this video. And I'm going to start build this infrastructure using Terraform. Right now I am on an empty directory, and I'm going to open this directory in Vim. So I'm gonna start by creating a file for our provider, and the provider is going to be AWS, and I'm going to use this region. Next, I'm going to create a different file, and this file I'm going to create the VPC and public and private subnets. So the first thing I need for our VPC is a CIDR block, and so this will be the network address, and I need to define the network bits. In our case it will be 24, and the reason is this VPC will only have 2 subnets. One of these subnets need at least 100 usable addresses, so each subnet need to have at least 128 addresses. So in total we will have 256 addresses required, and this is equivalent to 2 power of 8, which means we need 8 bits for our hosts. So we will need 32 minus 8, which is 24 for our network. So this will be the public subnet, and I'm going to associate it with the VPC I just created, and this one will be the private subnet. So I need to define the CIDR block for each of them. So the public subnet will have addresses from let me write it here, from this one to 127. Alright, of course not all of them are usable because we have the network address, we have the broadcast address, and we also have some addresses reserved for AWS resources. For the private subnet, so it will have addresses between 128 to 255. So to make the subnet public, I need to create an internet gateway, and I need to create associate this subnet with a different route table that will route all traffic to this internet gateway. So I need to put this internet gateway in the same VPC, and the same for the route table. And the route table will have only one route that will route all traffic to this internet gateway. And also I need a route table association to associate this route table with the public subnet. So these are all resources I need to make this subnet public, and let me put some comments here to distinguish between resources for public subnet and resources for private subnet. So for private subnet I will need a net gateway just to be able to access the internet to install packages and so on, and this net gateway will require an elastic IP address. So this net gateway, we need to put it inside a public subnet. So a subnet that has a route table that route traffic to internet gateway. Alright, so this is a public subnet, and we need to allocate this elastic IP address. Also I will need to associate it, we need to associate a different route table that will route all traffic to this NAT gateway. This time I'm using NAT underscore gateway ID. Okay. And I will need also a route table association. So I am associating this route table with the subnet, private subnet. Alright, I think that's all resources I need to set up a VPC with a private subnet and public subnet. I'm going to just open another window here, and let me just use my profile, and then I'm gonna initialize our Terraform, and after it finish I will run Terraform apply. So we have an error here at line 56. Yeah, it was misspelling of association. So we have 10 resources that are going to be created, which are these 10 resources. So I'm gonna just say yes, and after it finish I will go to AWS and see what we have created. So we should have one VPC and two subnets, and also 3 route tables, one for the main route table and 2 route tables for our 2 subnets, 1 internet gateway, and we have 2 NAT gateways, but one of them is actually something that I created earlier and deleted, and is still in the deleting process. So let's see what subnets we have. So you can see from the CIDR block we can figure out if it is public or private subnet, but also if you go to the route table you can see that this one routes all traffic to an internet gateway, which means it's a public subnet, and this one routes all traffic to NAT gateway, which means it's a private subnet. So I think everything is working as expected. Next I'm going to create the EC2, the public EC2 instance and private EC2 instance with the security groups, and try to SSH to them. So I'm gonna create a different file to keep my public instance and also the public security group. So the first attribute I need to define is a image ID, and for this one, if you try to launch an EC2 instance, you can find all images that you can use, and I'm going to use this one, Amazon Linux 2. Also I need to define the instance type. I'm going to define the smallest one. Actually the smallest one is nano. I'm going to use micro, and I need to define the subnet ID, which I'm gonna put it inside the public subnet. Also I will need to define the key name that we should use to be able to SSH to this instance. So I need first to create this key pair. So you can find it underneath EC2 features, and I'm going to create a new one here, and I'm going to call it, for example, test underscore user. Now I'm gonna copy this file into my current directory here. Alright. Next I'm gonna define the security group. So let me create it first. And for the security group I need to define what ports are accessible for outgoing traffic and for incoming traffic. So for outgoing traffic, I'm going to allow port 80 and port 443 for all IP addresses, so for internet basically. And I will also allow port 22, which is SSH port, to instances on the same VPC. And for incoming traffic, I'm going to only allow my IP address to access port 80 and port 22. So that's how you can find your own public IP address. There are hundreds of ways to do that. And because it's only one address, I'm going to use this for the host bits, for the network bits. And I'm going to also allow port 80. Alright, now I'm going to associate this security group with our AWS instance. And lastly, I need to associate a public IP, an elastic IP address. And I'm going to associate it with this public EC2 instance. Alright, I'm going to open another window on the right here and apply our Terraform. I'm just reviewing what I did. Yeah, this is a misspelling, so it should be without E. Let me try again. And I need to use my AWS profile first. Yeah, I think this is called VPC_security group IDs. So by the way, you can just go to Terraform provider AWS and you can find in this URL all resources. So if I try to find AWS instance, I can already see all attributes available here, and one of them is VPC security group IDs, right? This one. So after it finish, I'm going to go to AWS and check our EC2 instances. So I previously had 2 instances, but I deleted them and they are still in the termination process. So this is the one that I created just now, and the way you can know it, because it has a public IP address and it exists inside the public subnet. This is one of the addresses inside the public subnet. And also we can check the security group. You can see we are allowing incoming traffic from port 80 and port 22 for my IP address. This is my public IP address, and we are allowing outgoing traffic for these rules. And right now I'm going to try to SSH to this EC2 instance. So I have the key here that's associated with this EC2 instance. I'm going to use it. So this option -I will just define the identity file. and the username is ec2-user for this image, for this one, and we need the public IP address, which in this case is this one right here. So it gives this error because the test user permission is 664. We need to change the permission to be less accessible. So I'm going to make it 600. Let me try again. So right now I am on my EC2 instance here, and yeah, if I try to find, for example, the public IP address, it should be exactly the same as the one I tried to log in with. So next I'm going to run a web server on this EC2 instance. So I'm gonna just make this window a little bit bigger. Oops. Yeah, let me close this one. So right now I'm on my EC2 instance right here, and I'm going to try to run a web server using Netcat. So I need first to install Netcat. Alright, after it's finished, to run a web server, we can listen for port, for example 80. So you can access this web server on port 80, and whenever any incoming connection comes on port 80, we are going to execute this command, which in this case we are going just to respond with an HTTP response. And I need to pass this option -e to be able to interpolate this backslashes. I guess that's all I need. Yeah, so it will give you permission denied if you are trying to listen for port 80. So you have to run it as sudo. Now I'm gonna open another window and I'm going to try to connect to this public EC2 instance. So you can see I'm getting this correct response, which this one. But after I made the request, the server has closed. So if I try to run again, I will get connection refused. So instead I need to run this in a while loop. So I'm gonna open Vim here, and I'm gonna just run this listen command in a while true. So I opened here another terminal, but it is still in my EC2 instance, and I'm going to execute this server.sh that I created. Now if I try to connect to my server again, now the server is not closed after each request because it's inside this while loop right here. Next I'm gonna move this to user data, so to make our infrastructure immutable, so we can destroy it and apply it in different environments, or destroy it and apply it multiple times. So I'm gonna get back to my local machine here, and I'm going to copy the server.sh into a file I'm gonna call user_data.sh. And I will also need first to install Netcat. You don't need to use sudo when you are inside user data because it runs with root permissions. So right now let me try to exit from this EC2 instance and try to reapply my Terraform plan. So because I changed something inside user data, by the way, I haven't yet associated it with my public EC2 instance, so let me do it. So the second parameter here is the arguments, and we don't have any arguments yet. So after I change anything regarding user data, this EC2 instance will need to be destroyed and recreated again. So I'm gonna go now to AWS console and just refresh my instances. So this is my new EC2 instance, and you can check the user data from instance settings here. So you can see this is our user data, which is correct. Now I'm going to try to make an HTTP request to this to my public instance. So it still has the same public IP address. So now we are running an EC2 instance and it runs a web server. It's a very simple web server, but it's still a web server. So next what I'm gonna do is I'm gonna create 100 private instances. So let me first create the private EC2 instance. Let me exit from this one, and I'm going to copy this public instance file to private instance. Alright, so the file on the left is a private instance and the file on the right is a public instance. So I'm going to replace every public keyword with private keyword, and I don't need an elastic IP address for my private instance. And for outgoing traffic, this is fine except for SSH. Actually, I will leave it as is. But for incoming traffic, we should allow SSH from our public instance only, or from all instances in the same VPC. So I'm going to use this one instead. The same as for port 80. So let me try to reapply again. So right now I have two EC2 instances running. One of them has public IP address and the other one is a private EC2 instance, and it has this private IP address. So let me copy these addresses actually in a file, because I will use them right now. And I also need the private IP address, this one. So I'm going to try to SSH to this private instance, and the way I'm gonna do it first, I'm going to use the stupid way where I'm going to jump to my public EC2 instance, and then I'm gonna jump again to the private EC2 instance. And to be able to jump from the public instance to the private one, I need to have access to the key file. So I need to copy it from my local machine to the public instance. So let me first jump to this public EC2 instance. And if I try to SSH to the private EC2 instance, I will get permission denied because I need the identity file. I'm going to copy my identity file to the public instance. So I need to copy, So I need to use my identity file to be able to copy my identity file. It's a bit confusing, yeah. And for this one, I need the public IP address, and I'm going to put it inside /home/EC2 user. So after it finish, I should find it here, this one. Alright, so I'm going to use this one to jump to my private EC2 instance. Alright, so right now I am on my private EC2 instance, and we are also using the same user data, so I should have a web server running on it. So if I try curl localhost, so you can see we have this we have our web server running correctly, and we can even access this web server from the public EC2 instance. So if I try to go back to the public EC2 instance, now I am on my public EC2 instance here, and if I try to make a request to this private instance, I should also be able to access the web server. Now what I'm gonna do is I'm going to remove first this identity file from my public instance, and I'm going to use another approach called SSH tunneling to be able to access this private instance from my local machine while having this public instance in the middle. I'm going to write here the format of the command we need. So we need to define the option -l. This -n is optional, and this will just open this SSH tunneling without SSHing to this public instance. It doesn't make a lot of sense, I know, but you can try it out with -n and without -n. And the first thing we need to define is an available port on our local machine. So I'm going to just use port 6000. This is just a local port, okay? And next we need to define the private instance address that we need to access, and the private port that we also need to access. In our case, this will be this private port. This will be the SSH port, which is 22, but and actually SSH tunneling is actually used a lot with databases where they are kept in a private subnet, and you connect to them using a public instance in the middle. Next we need to define the credentials required to access a public instance, which in this case this identity file and the public IP address of our instance. Alright, so this will be the comment right here, and let me just format it a little bit. So the local port, I'm going to use 6001. This can be any port available on your machine, and the private IP address is this one, and the private port is 22. And I guess if we try to run this, so you will not see any output here, but there is an SSH tunnel opened actually, and we can connect to this SSH tunnel just using the credentials for the private instance, which is the same as the public instance, and also the username of our private instance, but instead of the IP address of the private instance, it will be the IP address of your local host. And also we need to define the port, which in this case 6001. So right now I am on my private EC2 instance. So now I have my VPC, I have my public subnet, private subnet, and I have only one public instance running and one private instance running. So right now I'm going to modify user data so that we make a request to the next web server online. And the way I'm gonna do it is whenever we are executing this the response to our incoming requests, I'm going to actually make another request to the next server IP, and this variable right here I'm going to supply from Terraform from outside. And if I go here to my public EC2 instance, this next server IP address, let me actually close this one so it will be visible to you. And this next server IP address for my public instance, it will be the private instance, right? and it will be the private IP address of this private instance. So if we try actually to reapply this again, now when I make a request to the public instance, yeah, so it will give you an error because we need to define the next server IP for also the private instance. So let me open the private instance file, and for this one I'm going just to give empty string. This should be fine if we make a curl request to an empty string. So we still have the two EC2 instances running. The public EC2 instance, if we check the user data, we should see that it is making a request to the private instance. Alright, so if I try right now to make a request to my public EC2 instance, I should get a response from my public instance as well as my private instance. Let me first change this hello world with some variables that I'm going to pass from Terraform from outside, and after each yeah, I'm going to just add a new line here, just keeping things organized. And for my public instance, the server info variable, I'm going to just set to be a public instance. Alright, so that's what I'm going to display for my public instance. And for my private instance, I'm going to so we will end up having 100 instances, so just the private instance is not unique enough. We should have here the private IP address of this instance. So I'm going to actually supply the private IP address manually, and we should have IP addresses from 129 to 254, right? So the first instance should have the IP address 129, and yeah, the server info is going to be the private IP address of this instance. So we can try to reapply this again. So I'm getting this error that this address is reserved because some addresses are reserved for AWS resources. So I'm going to start actually from address 133, and let me try one more time. So after it finished, you will have to wait a little bit for our instances to boot, and afterwards if I try to make a request to our public instance, now I'm getting the public instance response and the private instance response as well. So right now I'm going to create 100 instances, and each instance will make a request to the next server line. But actually let me start first with 3 instances, and the private IP address of the first instance is 133, but the second instance should be incremented by 1, and so on. So there is this variable that we can use, count.index, and add it to 133. So this will be the private IP address of our instance, and it will be the same as our server info. And the next IP address it need to make a request to, I'm going to just add 1 to this one. Alright, and for our public instance, let me open it here. Now we need to define which instance exactly we need to send a request to, and in this case it will be the first instance in line, right, which will have an IP address of 133. Now let me try to reapply this, and if it works I'm going to just change this to be 100, and it should also work. Let's see. So after it finished and our instances are booted, if I make a request to my public EC2 instance, I should get response from the 3 private instance as well as our public instance. So right now I'm going to change this value to be 100, and I believe it should work. I have never tried this before, so I tried before this video to run 3 instances and connect them together, but I have never tried this 100 instances before, but it should be fine. And after I create them, I'm going to just destroy my infrastructure, because it probably will cost me a lot if I kept them for one day. So I'm expecting this actually to take a lot of time here. Yes, I'm gonna stop the video, of course, and I will start the video again once it finishes. So right now we have 97 instances to be created. Yeah, let me click OK. So this is very unusual to actually create 100 EC2 instances. So even if you are in a microservices world, you will end up having 1000 ECS services, but all of these ECS services will be running on 20 or 30 EC2 instances, and these EC2 instances will not be micro. In this case, it will be large instances. Okay, I didn't expect this, so I got an error that I have requested more CPU than the limit of 64. I have never seen this error before, and yeah, I can adjust this limit by sending a request to AWS apparently, but let me check. I should have at least 64 instances running right now, and I believe let me filter them with an instance status. So how can I count them? I'm not 100% sure, to be honest. Alright, so I had to change the count to 63 because in total we can only have 64 instances. And right now if I try to make a request to my public IP address, I should see, yes, let me actually put them inside a file. So it takes some time to go through all of my instances, but hopefully I should see about 64 instances, which I do have 64 instances here. So yeah, this experiment is over. Now I'm going to just destroy all my infrastructure.